Okay. So good morning, everyone. Welcome to the day 3 of Openstack, and thank you for joining me on Sunday. So we'll start today's session. So I'll just start from the point from where we left last week. So last week we discussed about the Openstack ecosystem. So we saw there are services in Openstack which are meant for different purpose, and these different services we have seen are for different type of activities. So out of these some of them are like mandatory services or important for you to deploy OpenStack. Some of them are like experimental services, not like mandatory for your requirement, but yeah, depending on the use case you can utilize those services as well. Today I will talk about the OpenStack architecture. So the architecture which I'm going to discuss with you is the community OpenStack architecture. So community OpenStack architecture means that the design which I'm explaining to you is a generic one. It is not from the any customized vendor OpenStack. It is actually a design proposed by the community itself, and then the companies, they create their own architecture based on these baseline. So as per baseline OpenStack architecture, we need to have three nodes. Out of three nodes, one is optional, two are mandatory. So the very first node in OpenStack architecture is a controller node. So what exactly is a controller? From the name itself, you can correlate. Controller means that it is going to control the OpenStack architecture. It is not going to provide any end service, rather it is going to control or manage or do administration of the architecture of the OpenStack cluster itself. Then the second important node in OpenStack is compute node. So compute node is actually the node where you run your virtual machines. So in OpenStack, if you create an instance as a user, and you might be wondering that where that VM actually reside or where that VM actually goes in the physical environment. So whenever you create an instance in OpenStack, it goes on the compute node. And depending on the criteria, there are several criteria for selecting host. Based on that, the host is selected and your instance is launched. The third important node in OpenStack architecture is storage node. This storage node is basically, you can say, as an optional, because it is not important for you to have a storage node in OpenStack. But if you want to provide storage services to your client, like to the instances, then definitely you need to have a pool of storage. But if you say that I don't want to like provide any extra storage to any of my client, in that case it is not mandatory to have this storage node, but you might find this storage node in everywhere. Even though it is an optional here, but it's, still you find this storage node everywhere, because without storage pool it is no advantageous to have an OpenStack or any cloud infrastructure setup. So these three nodes are very important and they play their significant role in the OpenStack architecture. Moving ahead, I will explain you the extended architecture of OpenStack. So in extended open architecture of OpenStack, what does that mean? That there is an extra node. There is an extra node which is not mandatory, again not mandatory, but still from segregation of traffic point of view, some of the vendors, when they design their OpenStack, so they create a dedicated node. That node is used for the networking purpose. So whatever networking your instances is going to have with the external world or internally, they need to use this node. There's a physical node which is going to act as a networking node. So this you find very rarely, but still, because it is a part of the extended network, so architecture, definitely you need to be aware about this node. You might not find it in your official OpenStack, but still you need to be aware. So talking about control node, see, control node basically is a controller plane. So you might have seen similar kind of concept in Kubernetes also. In Kubernetes also we have a controller node which actually controls the Kubernetes architecture. Here also in OpenStack we have a controller node which basically controls your OpenStack architecture. Then we have the high compute node where actually hypervisor lies. So what is an hypervisor? I think you already know about hypervisor. If you don't know, don't worry, we will discuss about this in last of today's session. So hypervisor basically used to launch an instance. So these nodes where your actual instances get launched is called as the compute node. Storage node is actually a physical storage which provides you storage services. So there are three type of storage available, not only in OpenStack or not only in Kubernetes. It is actually in real time also, like real life also, in bare metal or previous traditional deployments also. You have seen there are three type of storage. One is your object storage, second is your block storage, and third one is your files system. These three different type of services, storage services, are provided to end users. And here we are going to provide same thing to OpenStack also. The fourth node, as I said, is an optional one, networking node, which runs your networking services. So this was about the basic architecture of OpenStack. Basic in the sense I'm just depicting here the node names, but I'm not giving you the actual diagram of the OpenStack. I will try to give you the actual diagram of OpenStack also in the upcoming slides. But before that, let me discuss about the deployment scenarios of OpenStack, because this is very important and relevant to you guys, because you might be wondering about how OpenStack gets deployed in your commercial setup or in your lab setups. So this is very interesting for you. So OpenStack deployment, as per the community guideline, there are two type of deployment methods. One is your framework for lifecycle management, and another one is your packaging recipes for the popular frameworks. Now, what exactly these two categories are? The first category says that framework for lifecycle management. Framework for lifecycle management means that you are not only going to deploy your OpenStack, rather you are going to manage your lifecycle of the OpenStack with the help of this framework. What exactly that means? That when you deploy, suppose you deploy some software in your machine. So what happens? You deploy using some method. Maybe in Linux you use a yum command or RPM command, or you use apt install, or different type of methods. So these methods basically install your software and then you don't control it, right? Suppose if you want to upgrade or if you want to delete it, then what you have to come, you have to again come back and you have to run that command, and in this way you manage the life cycle of that particular software. But when we talk about OpenStack as an architecture, as a cloud platform, so it is not simple that you just simply go and you just remove one RPM and your OpenStack is like upgraded or deleted or expanded. You have to follow some, because it's a bulky setup. So here we have a life cycle management. Life cycle management says that whenever you deployed your architecture, you deploy some extra node. That node basically going to take care of your complete setup in the for the whole lifetime. Whole lifetime means whenever you want to like expand your cluster, or you want to like scale out, scale in, or you want to like upgrade your cluster, or you want to downgrade, or you want to install your cluster, or you want to delete your cluster. If you want to do any operation with respect to lifecycle management, then you need to follow the framework for the lifecycle management. But if you are not willing to go with this lifecycle management, then there is a second category which says that you can just simply have the packages, and you can use your own tools to download and install those packages in the OpenStack cluster. But here you cannot maintain the life cycle of your setup. So talking about the very first example is a triple O. See, this is very popular method for deploying OpenStack in industry. So in today's time, if you work in any kind of OpenStack flavor, trust me, triple O is the most widely deployed and like you can say the very famous method for deploying OpenStack. What exactly is triple O? Triple O says that OpenStack over OpenStack. So it's three time O, OpenStack over OpenStack. So what exactly that triple O means, that you have to first create a basic OpenStack. That basic O, with the help of that basic OpenStack, you deploy your actual production OpenStack. So you have two OpenStack. One is first basic one, and then you have the actual one. What benefit you are going to get from this deployment? The benefit is that the base OpenStack which you are using to deploy your complete architecture is going to take care of your lifecycle management. Suppose in future if you want to expand your capacity, then you can use this base OpenStack for expansion. If you want to upgrade your cluster, you can do with the help of this base VM, this base machine. Similarly, if you want to like delete your OpenStack cluster, you can do with the help of this base machine. So this base machine is very important, and it is going to help you to manage your complete architecture in the commercial setup. So this is very, you can say, famous deployment method. And how does you start your triple O architecture? To start your triple O architecture, you have two methods. So I will tell you two different type of ways in which you can deploy your OpenStack. Now, I'm not going to talk about the deployment method, rather I'm going to talk about from where you start your deployment. So many of you might be having question that can we deploy OpenStack directly on physical server, or can we deploy OpenStack on an operating system or in a virtual machine or in a Kubernetes container? So these are the answers which I'm going to provide you for each of the deployment methods. So in triple O, you can start from bare metal. So bare metal means you can have a physical server and then you can start your OpenStack deployment. So purely you are going to deploy your OpenStack software on top of your hardwares. You don't have any middle software. You have directly OpenStack running on your physical servers. Alternatively, there is another way that you can start operating OpenStack installation within a triple O mode in an OS installed. OS installed means you already have a virtual, you can say an operating system installed. Operating system installed could be a case of bare metal where you have a operating system already pre-installed, or you have a virtual machine where you have an operating system installed. So you can start triple O deployment in both the methods, in both the ways you can start. Then we have is OpenStack Helm. So OpenStack Helm, so let me tell you that the other examples which I'm going to give you are not so popular, but rather they are the, you can say, a futuristic methods which community has proposed, and you might not find all of them in your industry example, in your industry use cases. Rather, you may find triple O only as of for now, but maybe in coming days or in future you will find all these examples also in the company releases. So talking about OpenStack Helm, so Helm basically, many of you might be aware that Helm chart is a method for automatic deployment of any pod in Kubernetes. So here you can deploy your OpenStack on top of Kubernetes architecture. Yes, OpenStack supports underlining Kubernetes architecture. So suppose if you have a Kubernetes architecture, in top of that you can run an OpenStack. So it is possible to run OpenStack on top of Kubernetes. Then Kola Ansible is a way where you have the Ansible framework where you can use it for the deployment of your OpenStack. And where does it actually start? It starts from the operating system installed. So for this, the condition is that your OS should be installed. You already have OS installed in your machines, and then you can do your Kola Ansible deployment method for OpenStack. Then you have Kyobe. What exactly is Kyobe? It is again a containerized method to deploy OpenStack, but it is deployed on top of bare metals. So if you want to have a physical OpenStack, like OpenStack deployed on physical infrastructure, but it is deployed in a containerized method, means the controller node. So I'm emphasizing on the word controller. So controller nodes are containerized. All the controller functions are containerized, but the VMs where you, I mean, other nodes compute, where you actually launch your instance, they are you can say they are not containerized. They are the actual services. Now OpenStack Ansible is another famous way to install OpenStack. You might have used triple, what we say like Packstack or DevStack. There are multiple methods to install file-based installation, question and answer based installation. So for these kind of things, we have OpenStack Ansible. Then we have OpenStack Charms. Charms is a containerized method where you deploy OpenStack on the bare metal. Then you have Bifrost, where you can directly install OpenStack using Ironic service. So Ironic service is basically a service in OpenStack. I will explain you in detail in the upcoming sessions. Ironic is a service which is used for the provisioning of the bare metal servers. So if you want to control or manage physical servers directly from service, it is possible with the help of OpenStack Ironic service. Then we have OpenStack Chef. OpenStack Chef is another way to deploy OpenStack. Now talking about the softwares, like directly installing software, you have Loki, lightweight OCI containers. Then you have Puppet OpenStack, where you can use Puppet to deploy OpenStack. Then you have RPM packaging. These are the three examples which I am taking right now, you can say are not so popular to deploy OpenStack in a commercial setup. Rather, if you are going with a commercial setup, it is always like recommended that you go with the framework for the lifecycle management, because it is very difficult to manage a commercial setup in with the help of only softwares. So definitely you should have a lifecycle manager. So I will explain you more in detail about the very famous method for OpenStack deployment in the next slide. So in the next slide, I'm going to talk about OpenStack architecture, which is triple O. See, this is very famous deployment, and in these sessions, in the all upcoming sessions here, I will discuss triple O only. I will not discuss any other deployment method, because this is the famous one which is used in the industry also. Other methods, if you want to explore, you are most welcome. Like you can go on the OpenStack community portal itself, where you find information about these deployment methods. See, at the moment, these deployment methods are not so popular, so it is it is more up to you. If you want to have an extra knowledge, you can definitely explore. But if you talk about the enterprise level setup of OpenStack, definitely you should learn about triple O architecture. So this is the one which is being used nowadays. So talking about, and let me tell you one more thing, that this is also going to be a dead technology in the coming days. Triple O is all, like you can say, or saturated, and the new deployment methods which I explained here, one of them might be famous in the upcoming days. So might be in our future sessions, we might be discussing on other deployment methods. But for now, I will be focusing on triple O. So here you can see in triple O architecture, what basically we have an OpenStack over OpenStack. So just a minute, let me change my mouse pointer. Okay, so here you can see this is called as the undercloud. Undercloud is basically a base OpenStack, where we have the OpenStack services. All OpenStack services are running. It is basically a single OpenStack. The purpose of this OpenStack is not to launch any VM for customer. Rather, it is just a simple OpenStack, and the purpose is to deploy complete OpenStack architecture, which is called as overcloud. So you can see this is called as overcloud, and in overcloud we have some set of nodes which have their own function. So the very first type of node is controller node. I explained in the previous slide that what is controller node. Controller node is used to control your OpenStack architecture. So it is used to function, it is used to manage, administer, it is used to do all the administration type of activities, even user management, everything is done with the help of this controller node. So we have three controllers. This is a minimum architecture. With like you can have more than three nodes, but it is minimum, you should go with the standard design. Then you have the compute nodes, actually where your VMs are getting launched. So whenever you launch any instance on OpenStack, they actually get hosted on one of those compute physical nodes. Now you have the storage node. So you have storage node for different purpose. So we have three type of storage. I mentioned you, there are three type of storage. One is your object storage, one is your block storage, and third one is your file system. Now block and file system, they come from single server. So we have external hard disk connected in a server, with a physical server. That physical server basically creates a service called block service, and then it creates a service called file service. These two services are then exposed to the OpenStack architecture, and then instances which are connected to, I mean, getting hosted on these computes, they connect to these storages using the different services of the and let me tell you one more thing, that this is not part of OpenStack architecture. It is a Ceph storage. CEPH might be my spelling. The way I'm pronouncing could not be easily understood for you. So I'm repeating the spelling. This is CEPH, Ceph storage. So whatever you see here, this block is basically a Ceph storage. This storage basically has a server, a physical server, and the hard disk connected to that server. So you can have a EMC storage, you can have a Dell storage, you have a Unity storage, you can have any type of storage which is connected to one of your server, which is not part of your OpenStack architecture, rather it is a Ceph server. Now this Ceph server exposes services. So what are the three type of services it exposes? One is your object storage, then is your block storage, and then third one is your file system. These three services are exposed toward the instances of your OpenStack. So this is an over cloud architecture. In vendor OpenStack, for example, I am taking name of Red Hat. So in case of Red Hat OpenStack, you find this undercloud node undercloud to be called as director node. So the what is director? Director basically manages the complete architecture, and this is called as the overcloud node. So as per community guideline, the base OpenStack is known as undercloud, and the actual production setup is known as the overcloud. So this is the generic terminology used by the community. Your company might give some different name to undercloud and overcloud, so that you need to check internally in your organization. Okay. Now I will move ahead with the specification of the hardware. So here, because we are going to deploy the different type of nodes in the OpenStack architecture, there must be some resources minimization. So minimum resources you need to have, more than that you can have as per your requirement, but these are the minimum requirement. For controller node to deploy, you need to have 1 to 2 CPU. You should have minimum 2 CPU for controller node. You should have 8 GB of RAM for your controller node, and you should have 100 GB of storage. 100 GB of storage is a local hard disk which is connected to the controller server. I'm not talking about external storage, I'm talking about the internal storage. So it should have 100 GB of storage. Then you should have two NIC cards. NIC card is basically a networking card, the similar one which you have in your laptop. You have an Ethernet port. So these kind of same porting we have in server also. So it should have two NIC cards. Then talking about compute node, it should have minimum 4 plus CPU. So it should have 4 plus. That is something you should always go with more than 4 CPU. This is like you can deploy with 4 CPU also, but it will be very difficult for you to provide service to any client for creating their VMs. So if they create VM, definitely you will not be able to fulfill their resource requirement. You should have minimum 8, more than 8 GB of RAM. Minimum 8, minimum is you should always go with more than, plus means that it should be more than 8 GB of RAM, more than 100 GB of storage, and then two NIC cards. Talking about the block storage node, see, block storage nodes should have 1 to 2 CPU and 4 GB of RAM and 100 GB of storage with one NIC card. Here the NIC card purpose is just to connect the actual data service, so the file service, the object service, and the block service. So all three storage service is going out of this physical server, this block storage node, with the help of this NIC card. So it is mandatory to have minimum one NIC card. You can have extra NIC card also if you want to have extra redundancy. But this is something I'm talking about the minimum deployment. You can have more than that also, it is most welcome. Now talking about the object storage, so same goes here with object storage also. So you should have 1 to 2 CPU, and then more than 4 GB of RAM, and then you should have 100 GB of, more than 100 GB of storage, and then one NIC card. So these are the physical requirement, resource requirement for your different type of nodes. Here I didn't mention about under cloud nodes. So you might ask me question that why you didn't include it under cloud node, because under cloud node is something different. It is not part of the actual over cloud architecture. That is why I didn't mention it. Now you can ask that what should be the what should be the configuration for your under cloud VM. So see, under cloud node, when you can have in different type of formats. Let me discuss this in upcoming slides. So let me park this question. Okay, I'm moving ahead with the important services in triple O architecture, because till now I explained you that we have 3 or 4 type of nodes in the triple O architecture. So we discussed, like, we have the controller node, we have compute node, then we have networking node. Then I talked about that we have your storage node. So we have 2 type of storage node: object storage node and block storage node. Now let me talk about the services which are running on these nodes, because for you it might be interesting to know what are the different services which run in your controller node, what are the services which run in your compute node, and what are the services which run in your storage node. So here, let me tell you that the important service in controller node is your keystone, which is used for the identity. I explained you in last week also that Keystone is one of the important service of OpenStack. Without Keystone, you cannot run any service in OpenStack, because it is used for identity service. It is used to identify resources, which resource is meant for whom. Then the next important service you find in controller node is your glance, which is your image service. Whatever images instances you are going to launch, you store the images of those VMs in your glance repository. Then you have the compute. So you remember that I explained you that there is a NOAA service in OpenStack which is responsible for managing or launching your instances. So that NOAA is not fully running in your in your controller, because I told you that controller only controls, it doesn't launch any instance. Therefore you don't find complete service of NOAA in controller. Rather you have a part of management layer of NOAA. So NOAA has different agents. So one of the agent might be running in your controller, and the rest important node agents do run in your actual compute node. Similarly for managed networking, So management part of a networking service run in your controller, but actual networking services, they do run on your networking node, or it could run on your compute node. Then you have a dashboard, a GUI, definitely a OpenStack dashboard GUI, which we call it as Horizon GUI. This GUI runs in your controller node. It doesn't run in any of your compute node. Then you have a database. OpenStack has a database. OpenStack supports both database. We have SQL and we have NoSQL. So I hope you already know what is SQL and what is NoSQL. So even if you don't know, let me explain you that SQL is a structured query language where you have a database defined with the predefined tables. So in table you have everything, all the parameters already defined. Now suppose what happens in future, if you decide you want to add one more entry in your database, but that particular entry is not supported by your SQL database, then what happens, that SQL, that your database reject that particular entry because it doesn't understand, it has a specific format. Nowadays we have a concept of NoSQL where we say that there is no structured query language. Whatever data you are going to provide, even if it is an extra attribute, it will accept and it will learn, and it will learn and adapt with that particular parameter. So instead of rejecting, it accept. So two type of databases are supported in OpenStack. An example, let me tell you, for SQL is your MariaDB. So OpenStack supports MariaDB, Cassandra. All the open source databases are supported in OpenStack. For you it is a choice, you want to go with the Cassandra or you want to go with MariaDB. Might be case that you may find in your company OpenStack supporting MariaDB, or maybe some different company OpenStack supporting Cassandra. Or might be, I have not seen any database till now used in OpenStack supporting NoSQL, but yes, it is possible. Might be a company who is designing a customized OpenStack could use NoSQL database also. Messaging queue, this is very important, messaging queue, because whenever we have so many services running in OpenStack, right? So each service has its own defined set of function, and now each service need to talk to different services. Therefore it is very important that the services should talk to each other, and it is not possible for all the services to directly communicate to each other, rather than they have a queue called messaging queue. So messaging queue, advanced messaging queue. So one of the open source example of messaging queue is RabbitMQ. You can use RabbitMQ. I have seen RabbitMQ in OpenStack, all the flavors of OpenStack till now, which I have used. But you might find some other messaging queue also might be suitable in your customized OpenStack. But this message queue actually take message from one of the service, and then without formatting, without processing, it simply pass that message to another service. Now, what is the benefit? Because this queue is going to maintain, is going to help talk one service to another. Therefore, your complete architecture is able to talk to each other without any problem. Then the next important service in your controller node is your NTP. OpenStack provides NTP service. Many of you know this word, NTP network protocol. So what exactly is this? You provide a time service, network time. Now what happens, suppose all your instances running in your OpenStack environment, they need to have a clock, and their clock need to be synchronized because they can go out of sync. Their dates could not match. So therefore it provides a synchronization. You could sync all the VMs with this NTP server because it is going to talk to external NTP server, external GPS clock, and in backend it can provide NTP service to the all the clients. Next important service in controller node is your orchestration, which is known as heat template. Basically, heat template or orchestration opens a door for automation. So suppose if you want to have an automation, you don't want to perform any activity manually, that you go and create instance, you create network, you create flavor, you create like volume, and then you create network, and then you launch instance manually. Rather, you have the predefined templates in YAML format. You can use those YAML formats to launch your instance automatically with the help of third-party tools. Also, it creates a stack. So heat create a stack between your OpenStack towards the other third-party system. So suppose you have a third-party machine which can fire commands automatically. Then it can create a stack between your OpenStack as a bridge. It can create a kind of a stack, and then you can use that stack to fire commands and manage the life cycle of your instances in your OpenStack environment. So this is your orchestration. Then the next one is your telemetry. Telemetry is basically a resource monitoring service. So whatever resources you are going to consume in your OpenStack, like your CPU, RAM, volume, storage volume, all these things you can clock with the help of telemetry service. Now here it is saying that minimum 3 nodes should be deployed. You should go with minimum 3 node of controller. That is the minimum configuration. You should not go with 2 node cluster of controller node. Trust me, if you go with the 2 node, you will be landing in a jeopardized situation where your cluster will not be able to take decision. So this is the minimum node. You can go more than 3 also, depending on the what type of design you are going to have. Now, talking about the services in your compute node. So I told you that compute node is a very light node. It doesn't have extra services. It does not need to have extra services. It don't need to have services like which we discussed in the previous slide, like controller having. So these things are not required to be part of your compute, because compute is going to provide your instances. So the hypervisor to launch VM is compute node. So basically what it provides a hypervisor. And in OpenStack, the service which is responsible for running instances is Nova. So Nova service runs fully on your compute node. And the default hypervisor in your OpenStack is KVM. It is a default one. It's not mandatory. If you want to have your own OpenStack, like for example, I take an example of VMware. So VMware has VIO, VMware Integrated OpenStack. So there they don't have KVM, they have their own OpenStack, I mean their own hypervisor. They have their own ESXi hypervisor. Similarly, networking services to connect VM to the virtual network via security group. So whatever network you create, it need to connect from your VM to your virtual network, because it is going to talk to external world. And there is a security group. Security group we will discuss definitely in the upcoming classes. It is basically a kind of firewall which prevents unauthorized entry and you can say incoming and outgoing of the communication traffic. So this networking service, if you are having inbuilt compute node with networking service, you will find networking in part of compute. If you have a dedicated networking node, you will find this networking to be in separate node. This is the only difference. Then talking about, and then it is saying that, okay, it will have telemetry also, because it need to monitor resources. It need to monitor what are the CPU, RAM, and all the parameters which you are going to consume from the instance level. It is going to monitor. Minimum 2 nodes should be deployed. You should not like say that I want to deploy on one single compute. See, one compute, if you deploy, it is not going to be beneficial. You should have minimum 2 nodes. And you know that the OpenStack is a cluster of, you can say cluster of computes. You're going to provide services to n number of customers. So you cannot go with 2 physical servers as a compute. Definitely you need to have minimum 2. And next maximum you can take depending on what type of data center you have. Like what is the maximum rack size? Because rack size is something which restricts your physical cabling. So it is important to have know the rack size. How many physical servers you can insert in your rack. Now talking about the block storage node. So I told you these 2 nodes are separate. They are not part of OpenStack. They are rather a different node. They are called as Ceph. There is a software called, another open source software called Ceph storage. That open source software Ceph provides services to client in form of three different services. One, it provides the block service, it provides the file service, it provides the object storage service. So three type of services are provided by the Ceph storage. For block and file, you can have a single server. You can have a single server from where you can provide these two services. But for object, you need to have a dedicated server. You cannot run object storage on block storage server. These two are two different type of physical servers. So you need to have two different. What actually you find in this block storage server, you find actual hard disk to provide block and file service to the OpenStack client. So OpenStack, it is going to provide service to OpenStack. It is not part of OpenStack. It is actually, you can say, a vendor to OpenStack. But because everything is packed together, so whenever you see your OpenStack architecture, you find Ceph storage also. But remember that Ceph storage is not integral part of OpenStack. Rather, it is a, you can say, it is a service, external service, which provide data storage service to OpenStack. Now you should have a data traffic flow towards compute is done on the management interface. So in your block storage node and your compute nodes, you have a cable. You have a cable which is connected to all the compute nodes from your block storage node, and you need to have only one minimum NIC node. So you can have one NIC card. If you want to have, you can have one NIC card, and then you can have minimum one node, physical node, and then you can connect, and your data will flow from block storage to your compute nodes, and then you can connect that volume to your instances. Object storage node, as I told you, it is a separate segregated service. It is not part of block storage. It is a physical different server. Here you find actual disk, which is used to provide object storage for storing account containers and objects. So data traffic flowing from compute is done on the management interface. So it also has a VLAN, it also has a like a NIC card, and that NIC port is connected to the all the compute nodes to provide the object storage service. Minimum 2 nodes should be deployed for your object storage. If you want to have an object storage service, you need to have two minimum nodes. You cannot go with 1 node. This is the minimum requirement for object storage. Now I will go with the next diagram. This is actually my last slide for today. And after that, I will take question and answer also. So here I have represented all the services which I discussed till now based on the role of the particular node. So for example, if I say controller node, if I say compute node, if I say block storage node, or if I say object storage node, these are the services which are going to run in those nodes. So let me just rephrase these services in front of you. Then after that, I will take question and answer. So SQL as I mentioned you that database, we have database service running in controller node. So we have two type of database service. So we have SQL service and we have no SQL service. Now let me tell you that you can have either one of them. You should not run both of them together because there is no point on running two different services which are meant for same purpose. If you are going to use SQL database on like MariaDB or Cassandra, you will have SQL service. If you're going to have no SQL service like Elasticsearch or different kind of database, then you can have no SQL service. Then you have database management service. Then you have message queue. I told you advanced message queue like RabbitMQ, NTP service, identity. I mentioned you Keystone, image service. I mentioned you Glance, compute node. I mentioned you that management of compute, Nova. So part of management, part of Nova, management part of Neutron. In networking you have different type of agents. So we have ML2 plugin agent. We have the Linux networking utilities. It is your Linux operating system networking utilities like bridges. So we have networking Linux bridge agent, we have networking L3 agent, we have networking DHCP agent. So suppose if you have a DHCP or a static network. So static network is something where you get a fixed IP, like you decide your IP by yourself. Client decide that which IP it want to use. In DHCP, the DHCP server allocate IP to the client. Networking metadata agent, block storage management, orchestration, object storage proxy service, shared file system management, telemetry agent, then telemetry management. These are the services which run in your controller node. In compute node, you have KVM hypervisor, then you have computes Nova, then you have Linux networking utilities, then you have networking Linux bridge agent, then you have the telemetry agent. Telemetry I mentioned is used for the monitoring of the resources. In block storage node, you have iSCSI target service, you have block storage, you have volume service, you have shared file system, you have telemetry agent. These are the services which run in your block storage. In object storage, you have object storage account service, object storage container service, then object storage object service. So these are the major services which run in your OpenStack environment on the nodes depending on the role which they are playing. So with this, I finish my today's part of OpenStack. Now we will open the forum for question and answer. So now you can ask me question on today's topic. You can unmute yourself and you can ask questions. Does anyone want to ask any question?
Hello. Hi, Krishna.
Yeah, hi. Hi, Amit.
Hi. Just want to know, can you give us the real-time example of some block storage and object storage?
Yes, okay. See, so let me give you an example of block storage. So you remember that we have a hard disk in our laptop, right? So hard disk is a physical storage. So physical storage means that you have a physical hard disk, you connect to your laptop, and then what we do exactly with that, once it get recognized, we create a file system. So block storage basically means you get the physical block of your storage. It is not having any file system, nothing, no intelligence, nothing. You simply take it, get it recognized with your operating system. Once it get recognized with your operating system, you create your own file system like XFS or ext3, ext4 or NTFS, or it is a Windows machine like NTFS or different type of file system. Once your file system gets created, then you can mount that particular storage to your particular directory mount point, and then you can start saving data or writing data in that particular storage. So this is the way how traditional storage works. So traditional storage means your block storage, where we get a physical storage and we create our own file system. Then after that we mount it to our respective mount point. Here's an example. Normal example is your hard disk, which we use in your laptop, or the hard disk which we use in our servers, which are directly connected to the physical servers. Now the next case is your object storage. Object storage is very special kind of storage. It is not like simple hard disk you take and you just create your file system and you mount. No, it is not like this. Basically, it is something different. Difference is that it is different on the physical level itself, physical layer itself. So you might have seen an example of library. So what happens in library when you go in a book library? So if you want to find particular topic, type of book based on certain topic or certain theme, then you go to librarian. Then librarian will redirect you to particular row number. That this particular row number is having, for example, you want to have a on particular technology you want to see book. So like you want to read a book on C++ or Java, then librarian will tell you that go to particular row number 4, and in that row number 4 you will find all books related to Java and C++. Then you go and then you pick your book. So similar kind of concept is applied in storage also. So what happens that you get attach a storage, you create a file system, you mount to your mount point, and then you start writing data. In that case, you have a control over the physical hardware of the storage. You know where actually your data goes. But here what is happening, it is a similar kind of library setup where the storage provider will decide how the data is stored. The storage provider will classify data on the basis of their category. So for example, you have a text file. If you have a like a audio file, you have a, you can say you have some different type of data. So depending on the type of data you store, the storage provider has its own file system. It has its own structure to organize data, and it store data according to its architecture. How do you get data? So point is that you have saved data, but now you want to retrieve it. So when you want to retrieve it, what happens? You get a metadata. So metadata is basically a small, you can say, tag or header which contains the actual information about your storage. Like if you have, like you have created a, you have saved some data. So for example, you have created a text file. That text file, it in the metadata, it will have the text file information, location, source location, where actually it is stored, and some headers to call that particular storage. Now what happens, whenever you want to retrieve your data, you have an API provided by your provider. Now your provider will give you an API. You hit that API with your metadata information, and then it will provide you that particular data. So you don't need to go and search, rather you will get your data. But here you should concern that you are not bothered about how the get data is getting stored on the physical layer. You don't know what is the file system. You don't know in which particular sector or which particular blocks your data is residing. So this is something where storage provider comes in picture. What is the benefit you are getting? The benefit you are going to get is that you are going to get a huge data size. You don't need to bother about the size limitation, because suppose you create a block storage of 1 TB, and 1 TB of your storage is, for example, over. Now what happens when you exhaust your capacity of 1 TB? If you want to expand, then you have a problem. Why? Because you have to expand your file system. You have to expand, you have to do, maybe you have to do remounting, you have to do LVM if you don't want to lose your current data. So you have to do so many things of task if you want to do expansion. But when you go with the this object storage, you don't need to worry. You take a capacity quota from your provider. You say that I want to store 1 TB of data today, and this is going to be my data type. Now tomorrow you come to your provider and you tell that, boss, I need to have 1 more TB of extra storage and just increase my quota, and I want to have some extra storage, and I'm not worried how you're going to take care about the file system and how you're going to take care about the actual residing of the physical storage. So this is the advantage of having object storage. But the disadvantage of having block object storage is that it is not that much fast. It doesn't provide you that high IOPS which you get in your block storage, because when you create your block storage, it is a kind of a, you can say, you maintain everything in your control, so you get very high OPS. So if you want to have a database, if you want to run a database, you should go with block storage. If you want to run a database, you should not go with object storage. But if you want to have an archive, Archive means you want to have an archive of more than 1 year old data. So for example, the media houses, so they have a content older than 1 year. So they know that this doesn't need to be retrieved immediately on urgent basis. It is something on demand. So even if the IOPS is quite low, this is not going to hamper their performance, because for the less than 1 year or less than 6 month data, they're going to have a block storage from where they can have a faster retrieval. But in case of having data store more than 1 year, so it is an archival. So definitely they don't care about the IOPS, so they go with the object storage. So this is an example of object storage where you want to archive your backup data, where you don't need it at the moment, but the retrieval doesn't matter. But capacity matters to you because you want to have extra space and you want to expand anytime without wondering or like you worrying about the file system or the capacity or mounting, remounting, or resizing. All these things you don't want to take care. Headache, do these headaches you don't want to put it on your head. So definitely you go with the object storage. And the third type of storage is your file storage, where you get file system already created. You just mount with your mount point. So example is your NFS. So suppose you get a Google Drive, OneDrive, all these kind of drives. So these drives you get externally available, and what you do is simply mount with your file system. You just simply download app in your synchronization app in your system, and then you start saving your data. So whatever data you are going to save is not going to save in your local machine, rather it goes directly in the external storage. So this is called your file service. So where you have already file, plug and play, you just plug it, mount it. So in case of file system, you simply mount. You don't worry about file system. You don't worry about physical storage of the data. So this is an example of three type of storages. So I hope it is clear.
Yeah, thank you. Thanks so.
Okay.
So,
Any other
Krishna,
question?
one thing
Yeah.
is it not possible that Google Drive can be considered as an object storage?
Yes, it is possible. Yeah,
Okay,
definitely it is possible, because you don't know, or I don't know how Google actually stores data. So they
right.
can have, definitely they can have an object storage. So just
Okay,
in like when we say that file system, means to me as a user, I'm getting a file to mount on my system, but I don't know. Maybe that file system could be like on backend, it could be an object storage.
okay, okay. Fine. Thank you.
Okay. Any other question?
Hi Krishna. So I want to know why we choose three controller.
Hmm.
Means any concept behind it.
Yes, there is a concept behind it. So let me tell you that let's start with one controller. So you have one controller and you are managing your complete architecture, and your one controller is down. So you know you have a downtime because you cannot have dashboard, you cannot have anything, you cannot control. Basically, you cannot control your compute instances. Now you go with a two controller node. So definitely for redundancy, you go with two nodes. Now there is a problem. If you have read about clustering concept, so clustering, any type of clustering, if you have read, so one of the famous clustering method open source is Red Hat PCS cluster, pacemaker corosync. So pacemaker corosync came up with a concept that yes, you can have a two node cluster, two node simple two node cluster, and you go with your deployment. Yes, it is possible. One node is down, one node will take care. It is possible, but there is a situation. That situation is that suppose your controller 1 and controller 2 are connected to each other, and due to any reason your connectivity, internal connectivity between controller 1 and controller 2 is down. Now controller 1 is master, controller 2 is also master. Now both of them, they assume that I am master, and they try to manage this complete architecture because they don't have internal connection. So they don't know who actually is master, because for controller 2 it assume that controller 1 is down because of some reason, it is not able to talk to, the heartbeat is not working. So controller 2 assume that controller 1 is down, and now I am the master of this complete architecture. Similarly, controller 1 is also assuming same thing, that controller 2 is down because of any reason, I'm not getting heartbeat, and controller 1 assume that I am the master of this particular architecture. Now both of them are in jeopardized situation, because both of them think that I am the master, and they try to manage the complete cluster. So in this way your cluster gets divided in two parts, split brain. So in order to avoid this split brain scenario, we have a concept called quorum. So you might read, you can read about this concept quorum, quorum, on Google also. So quorum basically says that to avoid such kind of a situation where we have two masters, and if there is a connection down between both of them, and they both of them assume to be a master, standalone master, to avoid this situation we have a voting concept. So voting concept says that whatever at any point of time, if any of the master or any of the I mean any of the member is down, there should be a voting done. Now voting, what exactly says that voting means that for example you have three node. So if you have three node, so it should be like divided by two. Flooring, you have the same voting concept in parliament also. So suppose if somebody want to bring a motion against any party, any ruling party, so they bring a motion. Now we go with the voting. So who has the highest voting percentage will be declared as a winner. Here also, suppose if out of three, so in case of two, suppose in case of two, you have two node cluster and one is down. So what will happen? Voting will say one. Here also voting will say one. So this is a situation that both of them has one vote. So you cannot decide who is going to be a master. Therefore, you have a three node cluster. So when you have a three node cluster, what happens? That at any point of time, one controller can be down, but two controller cannot go down, because one controller, when it goes down, you have two nodes and you still have a voting concept that you are providing, you're going to provide a voting, and these two are going to decide. Suppose if controller 1 says that I am going to be the next master, then it need to get a vote from controller 3 also if controller 2 is down. Or if controller 2 says that I am going to be master because controller 1 is dead, it need to get a vote from controller 3 also. So there has to be one extra member which can give vote, and then definitely the master can be decided. So this is the reason to have three nodes. So you should have minimum three nodes in your architecture. You can have five also, you can have four also, but it is better to have three, five, or seven, like these situations. So is it okay?
Yes, yes.
Yeah, so actually I gave you a different concept, different from OpenStack. It is actually a clustering concept. So you should always have three node as a minimum for any cluster to avoid any kind of situation. Okay. Any other question? No?
No, thank you,
Okay.
Krishna.
Okay, so thank you guys. Thank you very much for your time. I wish you all the best. So let's meet on next Sunday. So we'll come up with the new topics. I'll discuss about the OpenStack services in detail. So I hope this session was useful to you. So thank you. Thank you very much. Have a nice day. Bye bye.
Bye, Krishna.
Bye. Thank you.